Hey guys, so in this video I'm going to be trying to make a renewable source of fuel from two very primitive things. First off, a rock, and two, my urine. Yes, theoretically, I guess I could buy some. Well, I feel like this is pretty important to say. I kind of forgot to tell you that I'm talking about urea, not urine. I did not mean to buy urine. No, I thought I could buy urea. Not urine, not the same thing, but then it wouldn't be that renewable, right? I mean, this is from a natural resource then, right? So I guess in an apocalyptic scenario, you could actually do that because every step I'm gonna do in this process is it's very primitive. You could do this at home with no lab equipment. Well, you'd have to improvise a lot, but it could work. So I actually got this idea yesterday when I was thinking about someone, and I just got this idea. So let's get into the chemistry and all stuff. So P actually mostly consists of urea. It can have about 10 to 20 grams per liter. And when you produce like 1 liter, or let's say 1.5, then you can get up to 30 grams a day. And the thing is, I'm gonna have to step away from my rather fatty diet to a lean protein rich one, because urea is actually just a nitrogenous byproduct of proteins, because they contain nitrogen and the body really doesn't use that, so you need to get rid of it somehow. Quick biology if you care about it. And so I guess over the next few days or whatever, I will consume more lean protein to produce more urea, hopefully. And then urea actually decomposes naturally into ammonia, which you can speed this up very much with a base like sodium hydroxide. And I have sodium hydroxide at home, but you might think, well, sodium hydroxide, how the hell would you get that in the middle of nature, in an apocalyptic scenario, as I said? Well, sodium hydroxide is just what you need to make the ammonia itself. You can make the sodium hydroxide with something else. So this is the reaction between sodium hydroxide and urea. It also produces some sodium bicarbonate, right? And there is a way to turn this sodium carbonate. You can turn this sodium carbonate back into the sodium hydroxide, and you can do it with calcium hydroxide. I mean, you could theoretically use calcium hydroxide directly for the reaction, but it doesn't really dissolve that well. So I will do it with sodium hydroxide as an intermediate step, I guess, to make it react faster. Now you actually need to make this calcium hydroxide, and this is then the biggest problem, because I've had this rock lying around in my garage, I guess, for quite a while. I found it in the summer. I thought it was really cool, and I did some tests. I took some vinegar, poured it on it, and it started to bubble, which tells me there's a lot of calcium carbonate in there. And what you can do is you really heat up calcium carbonate, and this reaction occurs. So what you then get is calcium oxide. You can then put this calcium oxide in water, and voila, you get calcium hydroxide, which then I can use to make the sodium hydroxide and to make the ammonia with my P. So this is the full process, I guess. It's it's not hugely complicated, but the hardest part is turning the calcium carbonate into the calcium oxide, because it needs to be heated very much. Well, to around 700 degrees Celsius. I do actually have a furnace at home. It's able to melt a tiny piece of aluminum, so it's definitely able to reach 660 degrees Celsius in some regions. It's pretty weak, I guess. I mean, it can melt it, but not a lot of it. But I have made some upgrades, mostly just drilled a lot more holes in it to increase airflow and make that coal react faster. So let's get into the process of making it from my P, I guess. So here is the rock I was talking about. It's pretty big. What's this? It is pretty big. I wonder how I'm gonna get the calcium carbonate out of there. Well, the thing is, the calcium carbonate actually reacts with acetic acid, forming calcium acetate, And that's actually pretty good because, well, like silicon dioxide or whatever else this rock is composed of, well, probably doesn't react with acetic acid or dissolve in it, right? So I think what I can do is somehow dissolve the calcium part of this rock. How am I gonna do this? I don't yet quite know. Oh yeah, that's a lot more. Look at that. Yes, this is looking good. Yeah, I guess so. We do have some calcium carbonate right here, and that is great. Huh. Yeah, I do definitely need to filter it some, because when you think about it, I am scratching the surface open, right? So some dust and some non-calcium acetate will get in the solution if I don't filter it. Luckily, I have these filter papers now, wherever they may be right now. I have no idea. Well, I was trying to hammer that screwdriver in there to kind of, I mean, at least attempt to break it apart, right? But, well, that didn't go as planned. I guess I will have to, like, I don't know, powderize it somehow with, like, some kind of, like, means of friction. Wait, maybe with this thing? Yeah, and then I'll have to, like, save the dust somehow. Then try to dissolve the powder in the acetic acid, or, well, just vinegar, and then filter it. I did collect some powder. It is not enough, but I'm just gonna see whether it actually bubbles or if this just is another one. I really hope this is calcium carbonate, or else I did that with no purpose. Well, yeah, it's bubbling. I do not have anything bad to say, so I guess this is fine. I'll just keep on going. I actually got this little lab upgrade right here, heating and stirrer plate. Now I will stir this a bit to try and make as much calcium dissolve as possible, and turn on the heating too, because I mean, I really do want the acetic acid to boil off a bit. Now I will open up the windows, I guess, and just leave. Holy f***. It's in the middle of the night. I just remembered that I had this going. What the f***? So yeah, it's pretty burned. And now I've got some new vinegar. So I guess let's just add it in again. Is it bubbling? Wait, I think I'm gonna stir it. Okay, but it would kind of... Oh, come on. You can do it. Yes. It would make sense if it doesn't bubble any, because I mean, if it still is calcium acetate and the acetates haven't dissolved too much, I mean, it did seem burnt, so I guess some of it decomposed. Wait, did I say dissolved earlier? Anyway, if there was still a lot of calcium acetates, then again, they wouldn't really react, but I think there is some bubbling going on, so yeah. So yeah, I started up again, and I think most of what should be dissolved is dissolved already, because I mean, it was a powder, so it should have dissolved very quickly, and now I'm gonna filter it all to, you know, get all the impurities out, like silicon dioxide, and from this, you know, rubbing thingy. I really don't know what to call this. There's probably some iron oxide or whatever this material is some in here too. So now I will filter this to basically get some pure calcium acetate. Yeah, this can take a while. So now I put everything over, and here's the very solid stuff that stayed behind. I really don't know what to do with this, except for just throw it away, so this is what I will do with it. And I'm just gonna wash this down a little bit more, because, I mean, there's some bubbles and material still on top of there. But yeah, this is basically now my calcium acetate in some, well, water and acetic acid, so I will have to boil that all off. So I filtered it all off, and here is it, the solution. And now I am trying to boil it, and I have turned on the heating, but not really much is happening. This has been going for like 10 minutes now. Mistakes have been made. You know, I am filming this a bit after it all happened, But, you know, the glass was standing right here and, you know, it was very hot. And you see, I kind of, as with a few days ago, I kind of forgot it, right? So, come on. I did forget it, and then I just let it stand there, very hot, right? And then, well, after it all evaporated, the heat started going up, and, well, making this gross thing. And when I saw it, I kind of got anxious, immediately turned it off. And then you know why? After consideration and thinking clearly, it was stupid to do this because, well, it had no reason. But what I had in mind was having this really clean powder that, you know, isn't like this gunk. And, you know, when I then saw this gunk, what I did was immediately add vinegar again because I wanted it to be a bit liquid. Just again, the calcium acetate and some water and some acetic acid, right? But I didn't think that this was still very hot. And so when I just put it, it cracked, you know, and I got really anxious. Then you can see there's some powder coming through there. I guess now I will try to get out all the powder out of there. So yes, I actually did get the powder out. Now all I will have to do is, well, put the calcium carbonate into my furnace to get calcium oxide. Then put this in water and make it react with the sodium carbonate to get the sodium hydroxide back again, and, you know, repeat the process. So let's do it. This has to be the worst weather to do this. Like, look at it, it's snowy as shit. I really don't know what to do with all this snow, and I've, you know, gotta place the compressor somewhere, and it shouldn't also get wet, right? So, yeah. It's also like really cold, it's like -6 degrees Celsius. It'll get way colder because, you know, it does take some time for the coals to get burning properly, right? So yeah, not too great, but let's start it up anyways. I mean, I could just do it like next weekend, but, you know, I really want to do it now, so I guess this is just what I will do. Yes, this is a good opportunity to use my biodiesel. I made it in another video. Go check that out if you haven't. I thought it was one of the cool ones. Yes, here it is. It burns really well. Hopefully it does catch on fire. I used a lot on purpose because, well, in this video, in this weather, lighting things on fire isn't quite easy. This looks really cool. This looks really cool. I hope this catches on fire. I really do. Well, the biodiesel tried its best to light this all on fire, but I mean, it didn't do it. But I mean, it's not really the biodiesel's fault. There's only this much biodiesel that can soak actively into 2 pieces of paper, which might not have been enough, probably in this goddamn weather. So now I will use these little cubes. Well, they aren't really cubes, but it doesn't really matter. I mean, since I'm not really hindered in the ability to just add more, so I'll just add a bunch. And this is already a bunch, to be honest. It's pretty much... I know you can't see anything. Yeah, I mean, that's all I know, you can't see anything. So here's the calcium carbonate, right? And I didn't put it into my furnace for the simple reason is because I really don't want to. And I know this doesn't get as hot as the furnace itself. But, I mean, regarding the absolutely miserable conditions, can you blame me? Besides, this is just a demonstration anyway, pretty much. So, yeah, by the way, there is some aluminum foil on there for the simple reason is because the calcium carbonate does decompose into carbon dioxide, right? And I mean, this is just it's just a basically carbon dioxide machine. And the decomposition happens way slower if there's more carbon dioxide present. So what I tried to do is, you know, damn, that's glowing already in there. What I tried to do is, you know, kind of make it such that it doesn't all get full of carbon dioxide. I definitely won't be able to avoid that after some time. A lot of it will be CO2, but, you know, I really can't do anything about that. And yes, I will make this even hotter because I'm gonna get out the compressor now and, you know, pump some air into there. And, you know, as you know, with oxygen the reaction happens then way faster, which means more heat will be generated. So now I'm gonna start it up, I mean, and it's pretty loud too. been doing it for a few minutes now, and I think it's time to stop. Okay, that's pretty hard. So it's the day after that, and I've come home from school, and this foil is really weird. Well, it's looking completely different, which I guess is a good sign, which means it isn't exactly the same as before, right? So with the calcium oxide having been made, let's get to the urea. So luckily I had this apparatus because I wanted to make nitrogen oxide, or well, rather nitric acid. When I'm still experienced, it was long ago. I didn't. You might think now, well, I've watched every of these great guys, great videos. Yeah, you definitely think that. And I've never seen this one, but you know, I didn't post it because I didn't succeed. The reason is very simple. And it also was like, as I've said, a really long time ago. I wanted to make it with some of these little high voltage generators who say they can do 400 kilovolts, but that's not even close to reality. I wonder why they chose 400 kilovolts specifically. Like not 500, not 250, 400. Why? Write it in the comments if you think you know. And anyway, I still have it. Like, there's some one-way valves. This is really useless, but I mean, why take it off if you can just leave it on and not do any work? And yeah, so what will happen is there's a one-way valve right here. I'll put the sodium hydroxide in here and stir, maybe heat a bit too. I'm gonna see how much energy it takes for it to, you know, decompose or rather react with the urea. And then the ammonia will bubble through there, and right in here, there theoretically won't be ammonia, but ammonium hydroxide. Basically the same thing though. If ammonium hydroxide again evaporates, then it just makes ammonia again. And do you see this little thing flying around? They're everywhere. I have no idea what these kind of insects are, but they are everywhere. And when I say everywhere, I mean everywhere. Now let's get into making it from... Yeah, I'm hating this, but yeah, let's do it. So yeah, now here's the sodium hydroxide, man's most dangerous chemical. I mean, obviously I'm exaggerating, but this thing will kill you if it wants to. I think I'm gonna just put a relatively random amount in it because, well, I really don't know how much urea is in there. So I guess I'll just approximate it, close it up, and, you know, just start stirring and heating, I guess. And I will not drop it in on video because if I do, it might just start to go off. That possibility is like non-existent. Because, I mean, the concentration of urea isn't very high, and neither will be sodium hydroxide because I won't add too much. But still, you should be careful, or just do better research about this to approximate better what will happen. I choose the first one. By the way, you should also wear, like, safety gloves, and I do not have mine on, because I have them upstairs and don't want to get them, but you should. So I should have learned from old experiences. You know, back in the day, I used to make a lot of devices like this. You know, jar and then try to do something with it and make it airproof. However, the seal just would not work. No matter how often I did it, no matter how much super glue I used, no matter how much hot glue I used, it wouldn't work, right? So this was exactly like that, and I found out it was leaking. And, you know, I just threw it all away. And, you know, instead of me finding a great new solution to this problem that my things always leak, I'm just building another one, but this one will be really good. I mean, there will be no chance anything's gonna leak. And I'm certain, absolutely certain. Are you seeing this? Looks like the pH has risen. This is great. Now at first, you know what I actually just wanted to do about right now? Build a new apparatus with this, because this is way bigger. Well, at least in diameter. And what I wanted to do was do it like the original design. Because, you know, when you think about it, on top of the one-way valve, there's really a lot of water, right? So this is constantly pushing down it. I mean, it's not flowing through because it is a one-way valve. But now the air pressure on the bottom needs to exceed the one that's coming on it from the top. And some additional thing to actually trigger some additional pressure to actually trigger the one-way valve to actually open up, right? And I thought this wouldn't really be achievable, because if the pressure rose too much down there and basically all the air would be ammonia, then the hydrolysis really wouldn't happen anymore, or at least slow down. But looks like this is not the case, you know. I can see some bubbles right there, look. You see that? That's a bubble. You see those little pieces of everywhere. Look, I just got one. Look, I just got another one. You can just press down on them and they're dead. They are everywhere. What are they? Third time's the charm, I guess. Now, I kind of made this setup kind of like the first one, right? Basically the only difference between the middle one, the second one rather, and the first and this one was it didn't have an intake, which is actually really important because I then actually tested it out. I didn't film it because it was already like 10 p.m. and I didn't think of it, or I didn't have the motivation to. I don't remember everything. But whenever I blew new air into that, it started to bubble like really much, and then it just did nothing, right? Which, I mean, it's not really surprising. I guess I really underestimated that effect. And besides, you know, the cup I used to kind of hold the thing that would then hold the ammonium hydroxide, I'm sorry, big difference, actually broke. So I guess I had to make this new one. This bottle had been used in a setup like this, which I then threw away. And yeah, I know this one will work because different to all the others, I tested it. So it's like 5 minutes later, I did a pH test. Look at that. So it's definitely a good bit above 8.2. That's some fast growing pH. Yeah, I think I've exceeded it with this one very, very much. Okay. Now I've got some ammonia on this spoon right here. Let's see how well it burns. I've got my Bunsen burner active right here. Now I think I've got to like heat it up until it starts to boil. Because, well, I mean, this is just mostly water. And, you know, as you might have seen in my biodiesel project, lighting liquids up themselves is really not that easy. Hey, wait, that's burning well, god damn. You can really see the discoloration. Okay. So yes, I did it. I made ammonia from my urine. Now it's time to kind of recycle the sodium carbonate to get the sodium hydroxide back again. So I filtered it a few times now and it's green. Why is it green? Anyway, what I'm gonna do now is heat it up and make it boil, such that I can only get the powder, which will contain some part sodium hydroxide. And then, because sodium hydroxide is extremely soluble in things that are even just a little bit polar, I can just put some ethanol, or I think I'll use isopropyl alcohol because I have more of it. Yeah, there it is. I still have half a liter left. And yeah, that should then only dissolve the sodium hydroxide and only very, very minimal, basically non-existent amounts of other things that are in here. So let's do it. Let's get this to boil. Now, obviously I'm doing this outside. I mean, it's already not smelling too great in here. I mean, at least I can open the windows, but I guess boiling it in here would be the dumbest thing I could actually do. Well, the weather isn't very ideal. It's just like 3 degrees Celsius outside. Oh, plane. It's just like 3 degrees Celsius outside, and I mean, the aluminum foil is really kind of blowing away. I put it up here because, well, I want to insulate the whole thing because, I mean, it is kind of cold and I didn't want the whole heat to blow away, right? So I put some aluminum foil on there, and now, you know, one layer of aluminum foil already flew away. I wonder where it is. I'm not seeing it. How did it fly this far? What the hell? Okay, I've got some, you know, how am I not remembering how this is called? I'm gonna put this on there. So the dry powder smells very, very badly. Now, this is not surprising considering we are dealing with halfway decomposed or halfway oxidized organics, which create a really messy kind of mixture of organics, maybe volatile stuff, right? And that you shouldn't expect this to smell very good, right? So it usually doesn't smell very good. What the hell is that? No matter. Anyway, I added some isopropanol in there, and the reason I used that is because it's kind of polar. If it were too polar, I mean, I could have just used water, right? Water is very, very polar. And what would have happened if I'd used water is, well, everything would have dissolved, or like a lot of things would have dissolved that I didn't want in there. Now, luckily for me, sodium hydroxide is really, really soluble in a lot of stuff, including this, which is way less polar than water. But that's something good, because that means a lot of the gunk won't dissolve. Not all. Some will definitely dissolve into there. As I said, we might be dealing with some very mixed organic stuff. So a lot is going to dissolve in there, but not all. So I let this stir for a few minutes now. Now, the good thing is there's still a lot of powder in there, which means not too much has dissolved. Damn. Okay. I underestimated the smell of the isopropanol itself. I wanted to check whether the powder still smelled like that, but okay. I'm gonna transfer it to here, and filter some on the way. So now I'm filtering the isopropyl alcohol with the sodium hydroxide a few times, because there's still a lot of sediment in there, and I'm really getting a headache right now. So what I'm gonna do now is, I kind of thought it would be a waste to just make the whole isopropanol evaporate and just put it all in this basement, which then I basically some of it I breathe up again. I mean, the windows are open, but still it's not perfect. So now I'm heating it up to try and get it to boil. I put the aluminum foil over there such that I can make a small nozzle, because what I can do then, as soon as this boils, it'll all, or most of it, I didn't make this specifically airproof, didn't need to be. The isopropanol is ideally gonna go out this hole, and then I can just light it on fire and see it burn. At least that's the plan. This is starting to get really hot because it's also pretty loud. No? I don't want to go too low, because it might cause it to like all burn inside and do so very rapidly. This isn't an explosion per se, because it'll very probably be below, it will probably be subsonic, but still, it still basically is an explosion. Okay, it's starting now. Okay, I think it's time to turn it off. This is too much, dare I say. I'm loving it though. I've got this under control. I've got some water right here. That's crazy. Well, this is really relaxing. Just watching something boil and burn in my basement is actually pretty nice. I don't know about you, but I'm having a great time. So I put a bit of water in there to make whatever the hell this is dissolve as well as possible. However, it is kind of smelling bad, so this means it's not extremely pure. But I mean, it was expected for some random organic junk to be dissolved. So I guess, yeah, that's fine. Now, actually, I don't wish for too much basicness in a... Damn! Yeah, that's good. Now, I'm actually pretty surprised, pleasantly so, that I got this pretty high pH. I mean, as you can see, it was way over the scale. I mean, it wasn't much water, but what the hell ever, right? And I actually expected to get way less, just because, well, my setup that was making the calcium oxide wasn't particularly ideal. It was really late at night, the weather was absolutely horrible, and it was late. I didn't want to make the compressor run too long. It's like really loud. So, to conclude, yes, you can actually make a source of liquid fuel from your own urine and rock. You don't actually have to use a rock per se. I just used it because it was a good source of calcium carbonate for me. But calcium carbonate isn't rare in nature at all. For example, like wood ash mostly consists of it, and eggshells do so too. You need very much of them, obviously. But I mean, that's aside from the point. You could if you wanted to. Now, as the project, yes, it did work. I don't know why you would want to do that. But you can, so I guess... successful. Thank you for watching.